Hello. In this lesson, I want you to identify, graph, and describe parent functions. I want you to do transformations of parent functions. So a parent function is obviously one of the vocabulary words we're going to be talking about, along with constant, zero, identity, quadratic, cubic, square root, reciprocal, absolute value, and step and greatest integer functions, along with transformation, translation, reflection, and dilation. So a bunch of vocabulary is going to throw away. First off, a parent function is the most basic kind of function there is for a particular graph. It has no transformations. We're not changing it at all. So there's nothing to that. So it just starts off with the original. For example, a constant function is just going to be a horizontal line. And then what happens if your constant function equals a number, that's a transformation up and down. An identity function, that's your linear function. That's a straight line. Then a quadratic is going to be a parabola. We have a cubic. Those are polynomial functions. Then we're going to take a look at square root functions. And notice the square root functions forms kind of a gentle curve here. It only has one direction because you can't take the square root of a negative. The reciprocal function, you can't divide by 0, so you got these asymptotes on it. The absolute value function forms a v, so you get a v when you do the absolute value function. And then the greatest integer function. Now, let's talk about the notation of that. In the textbook, they use double lines for greatest integer functions. Sometimes you'll see it written like this. And sometimes it looks like just a double absolute value. Okay. What that means is I want to pick the biggest number that's an integer that's less than or equal to a number. So for example, if I have 5, the greatest integer function of 5, well, that's 5. Now if I go a little bit bigger than 5, I go like 5.2. That's also 5 because the biggest integer that's less than or equal to 5. And don't forget with the negatives, you got to think about what's less than or equal to. So if I do, the greatest integer function of, let's say, negative 3.2. Well, what number is to the left of negative 3.2 on the number line? That would be negative 4, because negative 3 would be to the right of it. Now let's take a look here, and we're just going to describe. We're not really doing any problem solving. We're just describing what we see. So I'm going to start here with, I'm going to describe the following characteristics of my parent function of the reciprocal function of 1 over x. I want you to find the domain, the range, any intercepts, any symmetry, any continuity, and the end behavior, and the intervals in which the graph is increasing or decreasing. So we have a lot to answer there, but you just go through it one at a time. So we'll start with our domain. Now I've got the parent function for the reciprocal on the previous page. So here we have our reciprocal function. Let me highlight that so we know what we're talking about this one. So if I look at my domain, what values of x is my function defined for? Looks like it's defined for everything except 0, because you can't divide by 0. So my domain is going to go from negative infinity to 0, and then from 0 to positive infinity. So it's going to be defined for everything except 0. Then let's look at our range. Our range are our y values, remember. So I'm going to go from negative, it's the same thing. I'm going to go from negative infinity, except it's not defined at 0. It'll never cross the x-axis. So our range is going to look the same. So my range is also from negative infinity to 0, and from 0 to positive infinity. Now, if I look at my intercepts, when does our graph, I'm going to make this a little bit bigger here. When does our graph cross the y-axis? It doesn't. When does our graph cross the x-axis? It doesn't. There are no intercepts on this graph. So we're going to say no intercepts. Now let's look at continuity. Can I draw this function without lifting up my pencil? And no, you can't, because it's not defined at 0. Pretty much what we said all along. And notice it has infinite discontinuity. Oh, let me show the graph here. At 0. So it approaches infinity at the 0. So I'm going to say it's continuous except, okay, we'll say it's continuous. I can graph the line without lifting my pencil, except at 0. Where it has infinite discontinuity. Okay, I think I skipped symmetry, didn't I? So let's talk about symmetry. Now, it's not symmetric with the x-axis. It's not symmetric with the y-axis because it doesn't flip across the x or the y. It is symmetric across the origin, so it's an odd function. So my reciprocal function, I'm going to say it's symmetric with respect, it has point symmetry with respect to the origin. Now, that's what we talked about the other day. This would be an odd function. Now let's describe the end behavior. Well, the end behavior is, remember, that's when it, what does it look like as it approaches really, really big x and really, really small x? Well, as x gets really, really big, it approaches 0. As x gets really, really small, negative infinity, it approaches 0. So what I'm going to say on this one then, I'll write it out like this. I'll say, as x approaches positive or negative infinity, doesn't matter, f of x approaches 0. Positive infinity approaches 0 from the positive side, negative infinity approaches 0 from the negative side. And then finally, when is my graph increasing or decreasing? Well, my graph is decreasing from negative infinity to 0 because it's going down. So I'm going to say it's decreasing from negative infinity to 0, and it's increasing from 0 to positive infinity. Make sure I looked at that right. It's actually decreasing both, isn't it? I just looked at that because it's going down. So I should have looked at my graph. I got to go back and change that. So it's decreasing the entire way. So I'm going to erase that, and I'm going to say the graph is always decreasing. So what happens when I try to go from memory instead of looking at it in front of me. Probably should have graphed that so I had the graph right in front of me.